All right, number 3. Okay. I have a line y equals x plus 4. Well, I don't know if you remember how to do this, but it does seem a little algebra heavy, but it's not completely illegal to do this. X plus 4 is going to be a line something like this. I kind of didn't want to be this color, but oh well. Actually, you know what? It wouldn't take that long. Let me just fix that. Okay. X plus 4 is going to look something like this because it has a slope of 1, meaning every time we go over 1, we go up 1, and it crosses the line here at 4. The y-intercept is 4. The next one isn't in slope-intercept form. This is the same as 2y equals negative x plus 8. And that's the same as y equals negative half x plus 8. Good thing to know how to, or sorry, plus 4. Good to know that. All right, so the intercept's in the same place, but the slope is totally different. It's negative half. So it's going to look more like, well, it's going to go through there, but it's going to have a slope of more like that. All right, now you can't see my 4. All right, this is 4 here on the y-axis. This would have to be, well, what would it be if x is 0? Y would have to be, oh, I did that already. If y is 0, x would have to be 8, so that's going to touch there. And on this one, this is this line over here, if y is supposed to be 0, x would have to be negative 4. So I get some critical points here pretty quickly. All right, the question is, determine the area of the triangle. Well, base and height are really easy to find here if I use this as the base and this is the height. I've already got the coordinates here, they'll tell me that. The distance from 8 down here to negative 4, that's 12. And the distance from here down to that side of the triangle, this is 4, because that's the height of this point. So half times base times height is exactly 24. Not a big deal. Boy's flying a kite with 150 feet of string. Didn't leave myself enough space to draw this. The string, so that'd be the distance from the boy to the kite. That's like the hypotenuse. And you can assume the kite's straight up. Straight up if we're talking angle of elevation. And that's where you draw angle of elevation. Angle of elevation is always, or depression is always to the horizontal. The question is, what's this? Well, with this 44 here, I'm talking about opposite and hypotenuse. That screams at me sine. Sine of the angle is opposite over hypotenuse. Now I used h for opposite. I know that you're probably mad that I didn't use O for opposite or h for hypotenuse, but h was for height here, so that's how that happened. So this is 150 sine 44. Some days this works really well. All right, 150 sine 150. So, I said 150. I really did. Come on. 150 sine 44. Probably some cool. No, it's not. To say it's probably some cool exact numbers. Now 104.2 is what we're going to say. Approximately though, 104.2. Okay, great. All right, find the measure of arc DE. This is what I'm looking for. And the circle with center O, good. Measure of angle A is 47. That's all they're telling me. And when they say measure of angle A, the only straight segments coming out of A are these two here, so they got to be talking about that angle that way. All right, if that is 47, then I know this arc over here, arc from B to D, is going to be double that. That's going to be 94. If that's 94, then, well, I got vertical angles here. If that's 94, this has to be 94. So I got 94 on that side. What else can I do here to try to help me find DE? Oh, I know, this 94 wasn't helpful. There's a diameter here from B across to E. And I know that, that's a really bad one. From B across to E is a diameter, so from B to E is 180. And I know this part's 94, so this part has to be 86. Okay, to make 180. Rectangular swimming pool has dimensions 50 by 20. You're swimming across the corner and you're walking around the triangle. So you're going to keep making this triangle trip over and over and over. You're going to draw the. You're going to travel the perimeter of this triangle. It sounds like 10 times. All right, you're going to swim and then walk, walk, swim, walk, walk, swim, walk. The hypotenuse is how far you swim. It's this far, which I can do on the calculator. 50 squared plus 20 squared is 2900. The square root of that answer, I just do that, oh cool, is 10 times square root of 29, which I would love to do. 10 square root of 29. So I have 10 square root of 29 plus 70. That's like the walking, and I take all that times 10. Okay. Plus 70 times 10. And I can also go bang like that. get something like, oh, cool, have factors this out. That's great. 1, 2, 3, 8, 5.2. 1, 2, 3, 8, 5.2. Something like that. Alright, segment CB is tangent. Alright, I'm into the part C now. I was going to stop making a new video, but I'm only 5 minutes into this one. Here we go. Segment CB is tangent to the circle, so that's one way to mark tangent. Radius 13, and BD is 10. Name a pair of similar triangles and justify. In a short paragraph, I would just say, in my test, justify why they're similar. Paragraph seems too much like proofs, and we didn't even do a lot of paragraph proofs, so that's no big deal. First of all, I have to know, and you know what? I'm just going to say it to you now, because you know how long it takes me to write stuff out with this silly pen. All right, I know this is. Let me just explain what I'm doing as I do it, and this would essentially be the paragraph. So you would just write down the important parts of this. I know this is perpendicular because this is tangent. So there's a radius tangent property or something like that. Again, I'm not going to make you say why it is, but you just know that the radius and the tangent are perpendicular. You also know that in a circle, if you have an arc where an arc intercepted by an angle on the circle, in other words, this point D is on the circle and intercepts this arc BA over here, and that's 180, this has to be half. So, and I think there was a special case of that for diameter. So if you have a diameter and connect it to a point in the circle, that's going to make a right triangle, because the angle in here has to be half of the arc it intercepts, and it's intercepting a 180 arc on the other side of that diameter. So that's a right triangle. So now I've got a right triangle here and a right triangle here, and of course there's a right triangle on both sides of that point D. So all three of these triangles have, it says pair, but I've got all three of these triangles have one right angle in them. Think about triangle, let's talk about the bad triangle. It's bad. It's BAD. It has angle A in it, and it also has a right angle. Well, so does triangle ABC. Now I need to make sure I write this in the right order. In triangle bad, B is the bigger acute angle, so C has to go C. A goes with itself, and in BAC, B is the right angle. So those two triangles are similar. You could also say that triangle bad is similar to the smallest triangle. In that triangle in BAD, D was the right angle. C was the bigger. Yeah, I could have also done this. CBD is similar to BAD. Either way, that would work. Okay, B, find the length of AD. Well, this is 10. This whole thing is 26. I could do Pythagorean theorem and find out. This one I can do in my head because of 5, 12, 13. Pythagorean theorem would tell me that has to be 24. I can do Pythagorean theorem faster than I can write. All right, 10, 24, 26 is a Pythagorean triple. Find the length of BC and DC. Well, I just said all this about similar triangles. So, and we have geometric means in here too. You can do that. 10 is the geometric mean. Do I need that one? I do. 10 is the geometric mean between AD and DC. So we can find that one pretty quickly. 100 divided by 24. That's just 25/6. Or if you really want that as a decimal, that's 4.16, and that is DC. And the other one I'm supposed to find is BC. Well, I could do Pythagorean theorem at this point, really, or I could say, you know, I'm gonna do the similar triangle thing. BC is the geometric mean of x and 25. You know what? Okay, fine. You call that y. Y is the geometric mean between x 25/6 and you know what? That's just nasty. Let's just do Pythagorean theorem. I mean, it works. Any of them work. Let's just go x squared in the small triangle. 25/6 squared plus 10 squared equals y squared. We'll find it that way. All right, 25/6 squared, 25/6, square that, plus 100, and then we'll take the square root of that, and we get 65/6. Oh, lovely. If you want that as a decimal, shame on you. Anyway, it'd be a 10.83. And that is, well, good, it's longer than 10, and that would be BC. Okay. Boy, that It takes up a lot of time, doesn't it? Note to self. Okay, sphere made of wax fits snugly in this box, so I guess we're supposed to believe that this thing is tangent on all 6 sides of the box. That would tell me that the radius of the sphere is 15. How much remaining space is there in the box? Okay, we'll just take box minus sphere. The box is 30 cubed. That's easy. Sphere is, when you know your formulas, not that bad. 4/3 pi r, careful, r is 15 cubed. Alright. Okay, which you can just do on the calculator, and it gives you this nice, perfect answer, or you can actually get a decimal, and it's something like 12,862.8. But, of course, I like this better, 27,000 minus 4,500 pi. Okay. Alright, if you heat the box and melt the stuff, how deep is it going to be? Well, it would be a rectangular prism that would be 30 by 30. And we don't know how high it would be, but we know that volume would equal this. It would equal 12,862.8. So I just divide that by 900, and I will get this. So take that number, divide it by 30 squared, and you get this height. It's a little less than half the height of the box, which is actually true. 14.3, I'll say 29. Oh yeah, and I should be better about that. Okay, great. Alright, in quadrilateral QRST, we have these angles. It says draw an accurate diagram. Oh, that's really hard. Let's start out with drawing a 60-degree angle. Call that R. I don't know how far this goes at all. But I know that the distance from Q to R and R to S is the same. So, okay, this part looks like a equilateral triangle. Q to R is the same as R to S. So if I was going to connect those, I'd have an equilateral triangle. I can do that. But then it connects to this other angle T over here, and this makes 90. So I'm kind of thinking we do something like this to make a 90-degree angle at T. ST is congruent to TQ, and those things are 10. Looks like a kite. Okay. Find the length of the two diagonals. Alright, so let's change color. That would be like from here to here. That's not bad. Q to S, this is B. Q to S is just 10 square root 2. That's no biggie. Well, if that's 10 square root 2, remember this is going to be an equilateral triangle, so all of these are 10 square root 2. It's kind of nice to know that. Okay, and I was also supposed to find the length of this diagonal from T down to here. Well, there's a 30, 60, 90 here. This piece, I think I'm going to do this in 2 parts. This little part over here isn't too bad. This is half of the blue one. So we're talking about T to R. It's a 5 square root 2 plus, and then so it's 5 square root 2 to here. This part's 5 square root 2. And then this little piece over here, well, this isn't a 30, 60, 90. If it's 10 square root 2, this would be half of 10 square root 2, which I know is 5 square root 2. This is 5 square root 2 times the square root of 3, which is 5 square root 6. And I think that's as good as I can actually make that. Okay, and for part C, back to red, find the area of the quadrilateral. Well, I've got 4 triangles here. The area formula for a kite, you could actually do the same as a rhombus. If I took diagonal 1 times diagonal 2, I would get the area of this. Well, that doesn't really show you very well. I would get the area of a rectangle that would be this size, and half of that rectangle, of course, would be the area of the kite. So I'm just going to do that. I'm going to do D1 times D2 times half. I'm going to do, because they made me find them, I'm going to do 10 square root 2 times 5 square root 2 plus 5 square root 6. Divide all of that by 2. Now I could have gone and done triangles. It would have been the same thing. It's fine. Okay, 10 square root. All right, 5 square root 2 plus 5 square root 6 times 10 square root 2. Cool. Divide by 2. I get that. I get 50 square root 3 plus 50. Okay, 50 square root 3. Alright. I just realized I messed that up on the homework or on the scan version of this, which I'm just going to take down when I put this thing on there anyway. When I took 10 square root 2 times 5 square root 6, I did 10 plus 5, and I got a 15 kind of thing in here somewhere instead of a 50. Anyway, so that was that. Alright, end of this video. I will go make a new one.